Yeah. Alright, so this is one of the questions he gave us in the lecture. So a solid E lies within the cylinder x squared plus y squared equals 1, and below the plane z equals 4, and above the paraboloid z equals 1 minus x squared minus y squared. The density is proportional to the distance from the axis of the cylinder. So that sentence is represented here, that rho equals a constant times the radius. So if you're ever given something like an exam where they say the density is proportional, it just means that rho equals a constant times the radius. Alright, and he's also given us a drawing of what we're looking at. So in this instance, x squared plus y squared equals 1 is the cylinder. Easy. And we're told that it's bounded below z equals 4, which is this plane. So it's everything below this plane and above this paraboloid. So this paraboloid looks like that. And you can see it there. Do you see it there? So it's everything above that paraboloid. And when you're given a question like this, the very first thing you should do is realize that you have to use cylindrical coordinates. It would be very difficult to do this just in regards to x, y, and z. So this is what it's going to look like. KR, then it's going to be dz r d theta. And the reason why you know it's z is because z is the height. So now we have to figure out what z is and then what r. So let's change color and get what is E equal to. And let us do this in regards to r, theta, and z. So just by looking at it, based on this equation actually, x squared plus y squared equals 1, we know that is r squared, and therefore r equals 1 because you square root both sides. So you know that r is going to exist between 0 and 1. In regards to the theta, it's just a complete circle, so you know it's 2 pi. That's easy. And then with respect to z, this is where it's going to become tricky. Well, actually, it's not that tricky, because you know that the biggest value is 4, and the smallest value is 1 minus x squared. So it's going to be 1 minus x squared plus, minus y squared is less than or equal to z is less than or equal to 4. And that's it. So knowing all this now, we can write our equation as, oh, that's an awful color. We can write our equation as, oh, and we'll also note that we're finding mass. So mass is just the integral. Just screw on with you. So you do the pi first. So it's going to be 2 pi to 0. Then you do the r, 1 to 0. And then you do the z, which is 1 minus x squared minus y squared. Oh, you already screwed it up. You already screwed it up. 4 is the highest value. And then, now before you write 1 minus x squared, how could you simplify this? So this could be rewritten as 1 minus x squared plus y squared, right? And we know that x squared plus y squared equals r squared, so we could rewrite this as 1 minus r squared, and that makes things a whole lot easier. So now we have 1 minus r squared. Perfect. And then we have kr, based on this formula, where, you know, density is proportional to the axis of the cylinder, whatever. And then we just have to go dz r dr d theta. And then we have to integrate. And so let's integrate carefully and not screw it up. So you're going to get 2 pi 0 1 0. Check k at the front because it's a constant. And then you're going to get, you're deriving with regards to z. So you're going to get, and you've got an r here, remember. So let's just square that, just get rid of it, r squared. It's not going to make a difference. And then we have to add a z because we're integrating with respect to z. And this exists between 4 and 1 minus r squared dr d theta. Having done this, we keep going to pi 0, 1, 0. We chuck 4 into the z slot, so we're going to get 4r squared. 4r squared minus r squared 1 minus r squared dr d theta, which is going to give us k 2 pi 0 1 0 4r squared minus r squared plus r 4, yeah, dr d theta. K 2 pi 0 1 0 3r squared, because 4r squared minus r plus r4 dr d theta. So the next step now is integrating with respect to r. So you're going to get 3r cubed on 3 plus r5 on 5. And this is between 1 and 0 d theta. Woo, right up there. So this is going to give you k 2 pi 0 r3 plus r5 on 5. So I'm just simplifying it down, d theta k 2 pi 0 1 plus 1 on 5. You don't have to worry about 0. Now you're going to integrate that with respect to theta. And you should be able to quickly do that in your head. So that is just 6 on 5. 6 on 5. Integrate it with respect to theta. You put a theta there. And then you're going from 2 pi and 0. Don't forget your k. And this is going to be equal to 6 times 2 pi on 5 times k, which is going to be equal to 12 pi on 5 equals to k. And that's the answer that he got in the lectures. And remember, this is your mass. So I didn't think he explained that well in the lectures. This guy isn't a very good lecturer. So I hope that makes more sense.